Hello ladies, today we're going to take a look at special extrema. So I'm going to save the trigonometric functions for class. We're going to skip to our piecewise functions, and in your white packet this is on page 5. So let me turn to page 5. When we're looking at piecewise functions, there are 4 important steps that we want to do. One thing is to note that every time we have these different pieces, those values are automatically critical numbers. Okay. We also have to make sure if the breaking point is continuous. If it's continuous, then we know that we can continue to do work with it. And then finally, we're going to take the critical numbers and do the same process, except we're going to make sure we're using the correct conditions. So that's all listed in 1, 2, 3, 4, and we'll do those in the next problem. So like it states, it says every time it's a breakpoint, that has to be a critical number. So what we're going to do is on the side, I'm going to label our critical numbers here. So automatically, all of my values, these negative ones and these 3's, have already become critical numbers. So I know my critical numbers right now are -1 and 3. Okay? And so before I can start taking derivatives, I want to make sure that these functions are continuous. So what I'm going to do is I'm going to plug in my breakpoints into the correct equations to make sure that this works. So f of -1 uses the first equation and the second equation. So I'm going to plug it into both. So I get -1 plus 3 squared, and that is equal to 2 squared, which is equal to 4. I'm now going to plug in -1 into the next equation. F of -1 is equal to -2 times -1 plus 2. And if we take a look at that, that will also give me 4. So since my left side is approaching 4 and my right side is approaching 4, we know that this one is continuous. So there is a derivative that exists here. So what I'm going to do now is I need to make sure my second breakpoint is continuous, so that will help me find out if a derivative exists. So if I take a look here, what we do is f of 3 is equal to, I'm going to use that first equation, so -2 times 3 plus 2 is equal to -6 plus 2, which is equal to -4. Then I'm going to plug in to the next equation, which is -3 to the third plus 12 times 3 squared. Okay, so to continue this, we are going to solve, and we get -27 plus 12 times 3 squared is 12 times 9, which is 108. And if I subtract these off, I will get 81. So if you take a look, these are not equal, which means that this portion is not continuous. If this is not continuous, then f prime of x is equal to an undefined value. Okay? So what we're going to do now is not only create our number lines, but we have to find our other critical points before we do that. So what I'm going to do is create a new page. And what I would like to do with this is continue just the same way that we've done our other problems. So on here, we've already found that our critical numbers so far are -1 and 3. We know that here a derivative exists because it's continuous. Here, f prime of x does not exist because it was not continuous. So if we continue this, let's go ahead and find the derivatives. And so as you can tell, I have to find 3 different derivatives, and I'm going to set each of those equal to 0. So f prime of x is equal to, let's see, the first one uses a chain rule, so I have 2 times x plus 3. The derivative of x plus 3 is 1, so I'm going to leave that there. The second one right here has a derivative of negative 2. And the third one has a derivative of negative 3x squared plus 24x. So what we're going to do is set these equal to 0. And then from here, we are going to have to make sure we use a correct derivative. So if I set this first one equal to 0, if I divide by 2, this cancels and gives me x plus 3 is equal to 0, x is equal to negative 3. And what I need to do is make sure that this value works. So this derivative works when x is less than negative 1. And here, negative 3 is less than negative 1. So this is a critical point that we have, negative 3. On my second derivative, I have negative 2 is equal to 0. Is that ever true? No, so I know that is not a critical number. And then I'm going to make some room over here. Let's scoot this over. I'm going to use a line to separate these. Okay, and our last one is negative 3x squared plus 24x equal to 0. What I'm going to do first is factor this out. And so let's pull out a negative 3 and an x. That leaves me with x minus 8. And so if we set these equal to 0, and if I set these equal to 0, this first part, negative 3x is equal to 0, x is equal to 0. And in here, I get x minus 8 is equal to 0, so x has to equal 8. So I need to check my conditions. When is this derivative allowed? Well, this is allowed when x is greater than or equal to 3. So according to this, I cannot use this value over here since that number is not greater than 3. So the other critical point I'm going to add up here is the number 8. Okay. So let's make our number line with our 4 different points and then see how this equation is going to work out. So if we pull out a number line, let's do it right here. And what I'm going to do is I'm going to go ahead and make sure we paste in the problem so we can see our equations. Okay, so just to get an idea, I had 4 different critical numbers, negative 3, negative 1, 3, and 8. And just to recall, my 3 derivatives were equal to 2 times x plus 3, negative 2, and negative 3x cubed, negative 3x squared plus 24x. Oops, it's squared, 24x. And just as a reminder, this factored into negative 3x times x minus 8. Okay, so we're going to use these equations to find the values of this different function. So let's finish this off. Oh, and I mislabeled this right here. This is an 8. So what we're going to do is that we're going to pick our test points, and we're also going to make sure that we write in our derivatives. So I know that at f prime of x, this derivative here was a 0. This right here was undefined. This right here is undefined. And this right here is equal to 0, right? So what we're going to do now is make sure we pick the right test points. So I'm going to pick -4, -2, 0, 5, and 9. Okay? So if I take a look at these different problems, -4 is less than -1. So I'm going to need to use that first derivative. And if I plug in a -4, that's going to give me a negative answer. So everything here is negative, right? If I plug in a -2, -2 is also less than -1. So I will also have to use that first equation, the first derivative. And if I plug that in, I'm going to get all positives. Then I look at number 0, and I see 0 is in between -1 and 3. So I will have to use the derivative of the second function, which is -2. Well, if the answer is -2, then that means my answer will always be -2. So I'm going to leave that as -2. I take a look at the number 5, and I see 5 is greater than 3, so I have to use the third formula that we have. And so if I plug in 5 into here, I get -15. If I plug in 5 into here, I get -3. A negative times a negative gives me a positive. So this is positive right here. And then finally, if I plug in the number 9, this will give me a -27, and this will give me a +1. So this will give me a negative. So if we were to interpret this information, and so what we see here is that we have a decreasing interval, increasing, decreasing, increasing, decreasing. And if I sketch this, this is decreasing, this is increasing. Then from -1 to 3, I'm decreasing. From 3 to 8, I'm increasing. And from 8 to infinity, I am decreasing. And so we can label our maximums and minimums. My minimum is here and here, whereas my maximum is up here and here. So let's go ahead and take a look at what the question is asking for. And what the question is asking is, what is the increasing and decreasing intervals, and what is the x values of my maximum minimums. Let's start with the maximum minimums. My maximum is going to occur, and if we make sure we label these correctly, my maximum is at x is equal to -1 and at 8. My minimum is at x is equal to -3 and +3. My increasing intervals are from, let's see, -3 to -1. I'm also increasing from 3 to 8. I'm decreasing from -infinity to -3. I'm also decreasing from, and let me see if I can make more room here. I'm also decreasing from -1 to +3, and I'm also decreasing from 8 to infinity. And this answers all the questions that this one problem is asking for. So in our next section, we're going to go ahead and take a look at our trig intervals and see how we can use this same function in our trig intervals. Thank you.